So, TypeScript. Okay? A study from 2022. Now, TypeScript was created. Why? Why was TypeScript created? Anyone? Let's hear from the class. What is TypeScript meant to do? Justice Bogner is chat name. OOP? Types? Okay. Anyone else? Don't be a piss baby like Spurs. I'm legitimately asking for things to read. I know Arvis is being real and I'm like trash talking him. Yeah, what's TypeScript for? Oh, we've got OOP, we've got types. Everything is in any. It's meant to DX your JS. Yeah. Mulroy. Son of a bitch, Mulroy. Mulroy coming in hot with a banger. YFan, remove a class of bugs. It was made to build VS Code. That's actually true. Yeah, no, Mulroy, I know you're serious. That's actually why it's funny, because it's real. It just made it more funny. I had completely forgotten about that. Then you bring it up as I'm having a sip here. I don't know why it was made, but I like that it at least has an LSP with auto completion and stuff. Sure, fair. Okay, yeah. I'm not going to argue against LSP, auto completion, things like that. I don't really have like, I can see the benefits of them, right? I think it's subjective whether you benefit from those or not, and so that's fine. If you benefit from those, you benefit from those. There's nothing wrong with that. Okay, so to type or not to type. A systematic comparison of the software quality of JavaScript and TypeScript applications on GitHub. Now, I'm going to warn everyone in case there are people watching who haven't been here before, because there are a few, I can tell. Look, if you go back to some of my previous live streams, I'm going to start condensing, like I'm going to slice these up and condense them down into smaller pieces. I've been doing this on purpose, and I'm going to post them on enlightenedprogramming.com. Whoops. Really? There we go. I want to change the color scheme, but I'm posting them here with articles along with the videos. So a written version of the video. Okay. So look, I read these all the way through. It is boring. It sucks. It's not as exciting as me, moving pixels around. All right. I've said this 100 times. The regulars are annoyed that I repeat myself over and over. But if you're watching this as someone new, I get it. This isn't exciting. But I do not see anyone else who is willing to even attempt to take a stab at defending the position that software sucks. And here are some actual academic reasons why they suck, why it sucks. Something at least to sink your teeth into. These things do not mean that like I can de facto state that I am right and everyone else is wrong, or something like that. But they at least help to open up the conversation. So I read through these as much as I can, and I apologize for the mind-numbing material. But we're going to do this. We're going to do this as properly as we can do it. I think it looks okay. Maybe what I'll do is I'll do this. Okay. JavaScript is one of the most popular programming languages and widely used for web apps, mobile apps, desktop clients, and even back-end development. Due to its dynamic and flexible nature, however, JS applications often have a reputation for poor software quality. While the type-safe superset TypeScript TS offers features to address these prejudices, there's currently insufficient empirical evidence to broadly support the claim that TS applications exhibit better software quality than JS applications. We therefore conducted a repository mining study based on 604 GitHub projects, 299 for JS, 305 for TS, with over 16 million lines of code. That's not bad. That's pretty good. Using SonarQube and the GitHub API, we collected and analyzed 4 facets of software quality. A, code quality, number of code smells per lines of code. B, code understandability, cognitive complexity per line of code. C, bug proneness, bug fix commit ratio. And D, bug resolution time, mean time a bug issue is open. For TypeScript, we also collected how frequently the type safety ignoring any type was used per project via ESLint. The analysis indicates that TypeScript applications exhibit significantly better code quality and understandability than JS applications. Contrary to expectations, however, bug proneness and bug resolution time of our TypeScript sample were not significantly lower than for JS. The mean bug fix commit ratio of TypeScript projects was more than 60% larger, and TypeScript projects needed, on average, more than an additional day to fix bugs. Furthermore, reducing the usage of the AnyType in TypeScript apps appears to be beneficial. Its frequency was significantly correlated with all metrics except bug proneness, even though the correlations were of small strengths. Our results indicate that the perceived positive influence of TypeScript for avoiding bugs in comparison to JavaScript may be more complicated than assumed. While using TypeScript seems to have benefits, it does not automatically lead to less and easier to fix bugs. However, more research is needed in this area, especially concerning the potential influence of project complexity and developer experience. So then they go over the history of JavaScript, TypeScript, some similar languages, kind of like some of the reasons why TypeScript was created. This sounds familiar. Didn't we read a similar article before? Yes, we've read a similar article before, not this one, but it was one that went over a variety of different languages. It wasn't just JS and TS. Actually, TS wasn't even in that one. It was something else. I don't even think JS was in that one. But yeah, it would have been similar. It would sound familiar. I am curious too. I wonder what they TypeScript performs. It does type checking at transpile time, yada yada yada, beginner friendly. Okay, so they don't really go into like a full history, so that's fine. So we've got JavaScript developed by Netscape in 1995, and then it has different versions, and now it's used by hate crime level things like Node and Electron. TypeScript is a superset created by Microsoft in 2012. It's got different types, different type notations. It's got a type system. So you have static type checks, and then you have dynamic typing, which only checks types during execution, which can lead to runtime errors due to incorrectly assigned types. And so this would be an indication of dynamic types in JavaScript. We all know that. So my string could be a string, or it could be a number. It just changes willy-nilly. And of course, developers, programmers have had issues with this because it's difficult to discern the type that you should be using based on this alone. You can alter the type at any point, and you never know when a programmer down the line, not understanding what you have done, will override the type of your variable. And so therefore, hey, why don't we have types like other languages have, so that we can enforce, some level of strictness with our types, right? And so you can see the difference here. You can't assign my string to 42 because it is set up as a type, and so on and so forth. Okay. So then they go over studies that were related. That kind of like touch on the same thing. So for example, so here's one that's a positive for TypeScript, okay? One of the few studies solely focusing on TypeScript and software quality was conducted by Gao et al. With the goal to investigate whether real-world JavaScript bugs could have been prevented by static type checking. They examined the bug fix commits and issue tracking of 398 JavaScript projects from GitHub. As a result, they found that using TypeScript would have prevented 60 of the 400 bugs they examined, 15%. That's not bad. Not a bad number. It's not the number that I would have expected. I would have expected TypeScript to save more, but it's still not bad. Just to be fair to TypeScript. So then they go over, we want to answer the following research questions. Do TypeScript applications exhibit better software quality than JavaScript applications? And do TypeScript applications that less frequently use the AnyType exhibit better software quality? And so they call it RQ1, RQ2. And this is sort of how they break down the hypotheses of different factors of the two questions, right? And so this is how they're going to approach it. Code quality. And so here are some definitions just so we can get a sense of what the heck were they looking at. Frequently used instruments to evaluate code quality are code smells. Example, indicators of low code quality which may impact maintainability. Detecting and removing code smells can also prevent bugs. To obtain the number of code smells per project, we use SonarQube, which is pretty standard. Code understandability is cognitive load, right? So when you're reading it, how much do you understand? Bug proneness is part to count the bug fix commits. These commits were identified by a script via commit messages containing bug and fix. This is the most accurate method with a precision around 95%. Manual examination of 500 commits classified as bug fixes confirmed this estimate in our sample. Therefore, we operationalize bug proneness as the bug fix commit ratio. So how many bugs were reported, and then how many bugs did you fix? Bug resolution time, which of course just means how long did it take you to fix your bugs. And so they described that. Then they took their sampling. They have they talk about the GitHub API, the breakdown of the files that they had to go over, how many lines of code, the number of projects, having to break out like how they're reading things, like how they're breaking things up so that they can get like total counts. So then they have like total lines of code for each one, total commits, total issues here, so you can break it down by the type. Then they go over how they collect the data. So this is an interesting one. For the bug fix commits, the script also examined if the bug concerns the primary language. Only if the file extensions JS, JSX, Vue, TS, or TSX were involved, the bug fix commit was included. So then they had to work within the GitHub API. Then they do their mathematical analysis on the difference, the delta, and whether it has a significant or an insignificant effect. They go over mean, median with quality differences. Okay, so they break that all down. They go over the any keyword, which, I mean, to me, I don't understand why you'd have a strict typing system and then have any in it. I don't know. It kind of boggles my mind, but it's okay. So they go over it. You can see that they kind of scatter plot their results so they can get a sense of some of the data. Okay. Discussion. In this section, we offer potential explanations for our results and discuss their implications. In both questions, we could show that TypeScript applications and refraining from using the AnyType are connected to improved code quality and understandability. The question remains, however, if our data is strong enough to suggest a causal relationship. One argument in this direction could be that TSC, which is the TypeScript compiler, warns about several facets of erroneous and unoptimized code, and thereby combats the dynamic and flexible nature of JavaScript. That is a good thing. Theoretically, this could have an effect on reducing some code smells, but still is unlikely to account for many others or for reducing cognitive complexity. So just because the compiler tells you that there is a bit of unoptimized code doesn't mean that you're going to go and optimize it and improve the quality or whatever it is. Another explanation could be that TypeScript may be more frequently chosen by experienced developers who may be less likely to introduce code smells in complex code. Experienced developers may also use static analysis tools to identify and remove code smells more frequently. Many of the TypeScript projects in our sample used ESLint, so the assumption that several also use SonarQube or other static analyzers may be reasonable. Another indicator for an experience difference could be much greater popularity of TypeScript projects in our sample. TypeScript apps averaged roughly 2,500 stars, while JS apps averaged only 604. That's huge. It's a huge difference. Despite TypeScript outliers like Storybook, like 68,000 stars, Code Server 51,000, or Grafana 47,000, the median difference is even more pronounced, 84 versus 738. Thanks, Travis. See you later, man. In theory, increased popularity could have the effect of attracting more skilled or experienced contributors. Nonetheless, JavaScript apps in our sample were from the top 15% of popular JS projects and also supported by numerous contributors, making it difficult to believe that their developers may be significantly less skilled than their TypeScript counterparts. Unfortunately, it is not really possible to directly control for the maturity or experience of the development teams with our study design. In other words, they don't have a way to confirm or not confirm that there are more or less experienced developers working on any of the projects that they did in these studies. Contrary to expectations, only a single one of our bug-related hypotheses could be accepted, namely, that a decreased usage of the AnyType is correlated with a faster bug resolution time in TypeScript apps. Now, what's funny about this is that the decreased usage of the AnyType is pretty much for the same reason that TypeScript was created in the first place. Essentially, JavaScript has dynamic types. So you could change a string, a variable that contains a string, into a variable that contains a number. If you set any on a TypeScript variable, you can essentially do the same thing. So you have literally solved nothing except added a complexity build step to your JavaScript. So of course it makes sense that if you're going to remove the keyword any and instead actually use types as they were intended to be used, then yes, you're going to resolve the issue of dynamic typing. Developers feel better because they can trust that the type of their variable is what it says. In comparison to JavaScript apps, TypeScript projects in our sample were more bug-prone and required more time to fix bugs. Moreover, a decreased usage of the AnyType was not correlated with fewer bugs. These results are counterintuitive to the theory that TypeScript developers are more skilled and experienced, as more experienced developers should produce fewer bugs. Project popularity, like stars, could be a confounder for bug proneness. More users will find and report more bugs, but we control for this by using the bug fix commit ratio, not simply the number of bugs. In our sample, there is no correlation between the bug fix commit ratio and number of stars. So popularity also fails as an explanation. The results also directly contradict Gao, who found that TypeScript can prevent 15% of JavaScript bugs, and Zhang, who found that dynamically typed languages require 60% more time for bug resolution than statically typed languages. However, both studies did not solely focus on applications, and the latter also did not include TypeScript in their dataset. Therefore, those two studies are difficult to directly map on to these results. One potential explanation could be that TypeScript is chosen more often for projects with very high inherent domain complexity, which could counteract any potential benefits for preventing and fixing bugs. Domain complexity is very hard to measure, though, and we know that TypeScript projects at least have significantly lower accidental code complexity. If we use size as a suboptimal approximation of domain complexity, we see that the median lines of code for our JS sample is 7.2 thousand, while it is 11.2 thousand for TypeScript, or more than 55% larger. While TypeScript with its type definitions is definitely more verbose, it seems unlikely that this alone would account for such a large difference. However, even if we assume the increased domain complexity hypothesis to be true, this still would not explain why a reduced usage of the AnyType is not correlated with fewer bugs in our TypeScript sample. A second potential explanation could be that TypeScript developers simply were more thorough in documenting bugs and their fixes than their JS counterparts. Both the number of commits and the number of issues are substantially higher in our TypeScript sample, thereby presumably supporting this notion. That JavaScript developers committed less could also indicate that they sometimes fixed multiple bugs in one commit, even though this is unlikely to result in such large discrepancies. As before, however, this theory would also not sufficiently explain the missing correlation between the degree of type safety and bug proneness in our TypeScript sample. In summary, the implications of our results are that using TypeScript and adhering to its type safety is associated with increased code quality and understandability, even though it is unlikely that it is directly and entirely caused by TypeScript. That's a very interesting statement. I just want to read that one more time. In summary, the implications of our results are that using TypeScript and adhering to its type safety is associated with increased code quality and understandability, even though it is unlikely that this is directly and entirely caused by TypeScript. Based on the comparison, JavaScript developers should be more conscious about code quality. However, the presumed benefits of TypeScript for preventing and quickly resolving bugs cannot be verified in the study, which hints at a more complicated interaction mechanism. At least in our sample of web applications, TypeScript seems not as superior for preventing bugs as often believed, and JavaScript does not need to hide here. If anything, TypeScript developers should not fall into a false sense of security. Lastly, while refraining from using the AnyType has some benefits, it does not seem to be significantly related to bug prevention. That is, TypeScript developers do not have to try to religiously avoid it at all costs. The effort may not be worth it in several cases. More research on this is needed. Now, if that's true, essentially what you're doing is saving a little bit. You're saving that code quality understandability, which goes back to what Ryan was saying. But you've added a build step or a compiler step in between, and an abstraction in a layer, and that comes at a cost. And the benefits of that cost are very unclear. They're very murky right now. So then they go over threats to validity, which every study does. And so sampling procedure is always an issue for just about every study. There are certain things that they might have excluded, and they realize maybe it's possible we excluded things that we shouldn't have. They only looked at the top 15% of repositories by popularity. It's not representative of everything. And And the fact that these projects also include other things that have an impact on like the project as a whole, right? And so they account for these things. Okay, so I thought this was very appropriate to Ryan's article over here about what are we adding to the cycle and why are we adding it and how are we benefiting from it.